Good evening, my beautiful people. This is Super Sanchez. I'll be reviewing part 2 of the quadratics review. Using quadratic, finding zeros, you will. Alright, so we're going to get started with number 1. The graph shows two parabolas, one of which is described by f of x equals x squared. Which function describes the other parabola? Okay, one of the things you need to know is, do you know what causes all the rules? Okay, so in this case, if the red parabola is x squared, and then the new one is the blue one. Okay, so the parabola actually got narrow, so you have to know the rules for what causes things to be narrow, and so we'll go from there. So if you multiply by a number greater than 1, it will cause your parabola to become more narrow. Okay, so that answer is letter C. Okay. Now, what if you don't know the rules? What is your plan for figuring that out? So I'm going to show you. What you're going to do is you're going to go to your graphing calculator and graph x squared onto the calculator like that. You press tab and you type in the first one. Let's say 1/3 x squared. Let's see what that looks like. And does not match the picture. So you could double click on that. Let's take off that 1/3 and put -3. And that definitely does not match it. So again, you double click, you add 3, does not match it, double click it again, and change that to the answer choice I picked. Oh, look, it's exactly like what we have on our problem. Okay? So use your graphing calculator. This test is going to be big on graphing calculator, but you do need to know how to use it. Alright, number 2. Number 2, what are the characteristics from the table below? To find your vertex, you need to look at your y's, and you need to find when it starts repeating. If you notice in the y values, the y's, this 8 does not repeat. So it's right in the middle between these two numbers repeating. Okay? So our vertex is -3, 8. Okay? So now our axis of symmetry again is x equals -3. Again, you must remember the x. We still have issues. Y'all need to remember that. Okay? Alright, next is our y-intercept. You got to remember that our y-intercept begins with 0. Okay? So if you look at the table, right here, we have 0, -1. Okay? And then our domain is going to be all real numbers. Okay? And our range, in order to discover our range, we need to start looking at our y-axis, not our y-axis. Look at your y value of your vertex. Okay, so here's the vertex, and then you go and look at the number next to it. It went from 8 to 7 to 4 to -1. So my y values are going down. So y values going down. Since it's going down, that means the parabola is opening down. Okay? So that means y is less than or equal to 8. Okay? Alright, so now let's find the x-intercepts. One of the things that you need to know about your x-intercept is that y equals 0. So if you look at your table, we do not have a 0 value in the y column. But 0 would not be between 8 and 7, would not be between 7 and 4. It would be between a positive number and a negative number. So 0 would actually be located right there. So that means that the x-intercept would be between -1 and 0. So let's write between -1 and 0. Okay? So, and the reason why is because that's where y equals 0. You got it? Alright. Okay, so let's look at number 3. Which transformation which describes the transformation of the graph f of x equals x squared to the graph of g of x equals 1/7 x to the power of 2. So again, you must recall the notes that we took in class. It has to do with this part of your notes. Again, it's been multiplied by a fraction, and it's on the inside. So both of them, either way, they're both a compression. Okay, they're both a compression. So just let's look at some words right here. Horizontal translation means left to right. So it's not going to be that one. Reflection means that it goes upside down. It was not negative. Horizontal stretch is, again, imagine the parabola going like this and then somebody pulling up his arms. And then vertical compression is that somebody pushes down on the parabola and you get that. Okay? So if you remember this, the answer is going to be letter B because it's a fraction. Now, what if you don't remember this? Okay, so what do I do in those cases? So in those cases, we're going to bring up the graphing calculator once more. You graph the parent function, and then you graph the second function. As you can see, imagine that somebody pushed down on the arms. Okay, they pushed down from above and made the arms open up. Okay. Now, while I'm here, I also want to express that this is a compression by a factor of 1/49. I mean 1/49. Now, where did I get that number? Well, this means 1/7 x times 1/7 x. Well, what's 1/7 times 1/7? 1/49. 1/49 x squared. So again, if they ask you about what factor, this is going to be a factor of 1/49. Okay? Alright, so let's go to number 4. How is the graph of y equals 5x squared plus 3 different from the graph of y equals 5x squared? Okay, so again, it helps that you know your rules. Hopefully you've learned that adding a number moves the parabola up d units. So in this case, we can eliminate C and D because they say right and left. And of course, the correct answer, how is it different from the graph of 5x squared, is that it went up 3 units. Now again, we're going to bring up our graphing calculator, and this is what you need to do if you do not know your rules. You graph the first equation and you graph the second equation, and then you can compare. The blue parabola, which was the first one, is up 3 from the other one, okay? How is the graph of 5x squared plus 3 different from the graph of 5x squared? So again, the blue parabola is up 3 from the red one, okay? So that's why it's B. So you got to be paying attention to how they ask which one they're comparing it to. Alright, number 5. What are steps transform the graph of yx squared to y equals this equation? Okay, so again, this brings up these rules. And you're like, again, yes sir. So, if you don't know this, then plan B is to graph both of them. Okay, you should be able to graph both of them. So as you can see, the red parabola, which is our parent function, is now upside down. So you're supposed to know that this negative sign right here causes a reflection. Okay? And then the next thing you're supposed to know is that this 3 causes the parabola to become narrow. As you can see, if you look at the red and then look at the blue one, it's a little bit more skinnier than the red one. Okay? And then you're supposed to know that this negative 2 moves to the right 2. So let's look at the vertex. If you see this vertex, it went over 1, 2, okay, to the right. And then the 3 out here on the side, it moves the parabola up 3. So again, let's look at the vertex. It's not here on the x-axis, it's up 1, 2, 3. So it went to the right 2 and up 3. Okay? So those are the changes. Again, if you don't know the rules, learn how to use that graphing calculator in your favor. Alright, number 6, what are the zeros? We have x plus 6 and x plus 10. Our zeros, remember your x lies. It's always lying to you. So our solutions are x equals negative 6 and x equals negative 10. Easy breezy. Now the fun part is to change this into standard form. We learned the box method. Okay, x plus 6 and x plus 10. So we're going to do x times x, which is x squared. We're going to do x times 6, which is 6x. And then we're going to do 10 times x, which is positive 10x. And then we're going to do 10 times 6, which is 60. Now don't forget we have a peanut right here in the middle, which we combine our like terms by adding. So our standard form is x squared plus 16x's plus 60. Okay, so that is our solution. Now please, 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 please check. You can check by graphing this and graphing this. If you did it right, they will line up. Now let me demonstrate what I'm talking about. So I'm going to go to my graphing calculator. Okay, let's go to the second page here. There's the first problem. Okay, so if I press tab and I graph my answer, which was x squared plus 16x plus 60. Watch for the magic. Voila. Do you see that the green parabola is on top of the red? So that means I did it right. Hooray. Hip, hip, hooray. So what will happen if you didn't do it right? Let's say I got minus 16 for some crazy reason. Notice that the parabola does not line up, so that means I did it wrong. Okay? So again, check your work. No reason for you to get this stuff wrong. Alright, number 7, rewrite the following from vertex form to standard form. Alright, so before we begin, we must rewrite this. This is x minus 3 times x minus 3, and then minus 1. Now, in order to multiply this, hopefully you have learned that you must do the box. So off to the side, we are going to do the box. Now, some of you have discovered the pattern of how multiplying, we call this a perfect trinomial. Okay, there is a pattern to this madness. It's always going to be x squared, and then it's going to be minus 6x, and then plus 9. You're like, what? Negative 3 and negative 3 is negative 6. Negative 3 times negative 3 is positive 9. So if you learn this, guess what? You don't longer have to do the box method. Unless your teacher says, please show me the box. Okay? But here's the work. If you didn't understand the pattern, just do the box, do the regular work. Now the next step is we must distribute this negative 2. So we get negative 2x squared. Negative 2 times negative 6 is positive 12x. And then negative 2 times 9 is negative 18. And then we got this minus 1 on the side. So guess what we must do with our like terms? Negative 2x squared plus 12x minus 19. Okay? And bada bing, bada boom, we are finished. Now once again, please, 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 please check. It doesn't hurt you to check. And what I mean by checking is that we're going to graph the problem. Okay? And when I say problem, I'm talking about this. And I'm going to graph my answer. So check this out, folks. Again, I go to my graphing calculator. There's the first one, right? I press tab, and I believe it was negative 2x squared plus 12x minus 19. Okay? If I graph them again, the parabola ended up on top of the other one. So that is telling me I did this correctly. So please, again, hey guys, use that resource. Now again, you must know how to multiply. Okay? That is your goal. Alright, so let's continue with number 8. You can verify the zeros of the function by using a graph and finding where the graph crosses the x-axis. Crosses the x-axis. Okay, zeros are located on the x-axis, okay? Alright, the solutions of a quadratic